Welcome to the Click. Today we will learn ratios and proportions properties. The learning targets of today's lesson is learning how to find the unknown in ratios, learning proportional division, which both are ratios properties, and learning proportions properties. Okay, starting with ratios properties. Firstly, let's find the unknown in a ratio. If the ratio between two quantities and one of the quantities are known, the unknown quantity can be found using the following steps. What do we mean by this? So I have, for example, a ratio, okay? 3 to 5. This is known, okay? I know this. And I have the quantity of 3, which is 18, for example, okay? I have these two. And with this data, I can find the quantity of 5. I don't know if I should, name it data or data, but let's not focus on that. With these two, I can find the quantity of 5. This is the whole point. How can I do that? Put both the ratios in an equation and then put an x instead of the unknown quantity, okay? Quantity, and use cross multiplication after that. This is very, very simple. I have two questions. The ratio of boys to girls in a class is 3 to 5. If there are 24 boys, how many girls are there? So the ratio of boys to girls in a class is 3 to 5, right? And we have 24 boys and X number of girls. Why? How I know that 24 is the quantity of 3 or the quantity of, 3, yeah. Because this says that boys to girls, 3 to 5, right? And boys are, 24, the number of boys is 24. So 3 to 5, 24 to X, because boys to girls, boys had come first in the question. Okay, so now let's write them in a fraction form. 3 to 5 equaled to 24 to X, right? Now let's just do cross multiplication. X equaled to 5 times 24 divided by 3. So 5 times 24, 5, 4, 0, 5 to 10 with 2, 12, 120 divided by 3, which will be 40. So there are 40 girls in the class. A mixture of two substances is in the ratio 3 to 5. After adding 12 units to the first substance, the ratio becomes 1 to 1. Find the original quantities of both substances. I have brought this question for you to really get you known and get you understood with the types of questions that in this topic you will get, okay? Because normally teachers would, solve the simple questions, and when in exams or when, you need to, you are on your own, at that time it's really, really hard. Hard questions are coming. You need to really, really concentrate. So I try to, get you noticed and get you known with the hard types of questions, okay? So this is a hard type of question for finding the unknown in a ratio. It says a mixture of two substances is in the ratio 3 to 5, okay? So what this question wants from us, it wants the original quantities of both substances. So we should focus on that only. We should not focus on the side parts. We should only focus on finding the original quantities of both substances. How we can do that? So for the quantities, I can name the quantities as 3x and 5x. 3x and 5x, right? I can name them as 3x and 5x because these are the original quantities. Okay, and I need to then add 12 units to the 3x, which is my first substance quantity, right? So it's 3x plus 12 divided by 5x. If I add 12 units to my first substance, which is 3x, right, to my first quantity of substance, then both 3 to 5, those two will be, the ratio of them will be 1 to 1, right? So that's why I say that 3x plus 12 is equal to 5x, right? Because the ratio will be 1 to 1, and 1 to 1 means, equality. So right now I know I have the whole equation with me, so I just need to simplify it. Moving this to the other part of the equation, so 12 is remaining in here, 5x, because the symbol of this was plus, the symbol of this will be minus, not 3, right? 5x minus 3x. Okay, so this will be 12 equal to 2x. And now I need to move the coefficient of x to the other side of the equation, which will be x equal to 12 divided by 2, which is equal to 6, right? So I had the quantities, which were 3x and 5x, and I have found x, right? X is equal to 6. Now I need to multiply them by 6 only. So 3x multiplied, not 3x. I can write it like this. It's okay. 3x equal to 3 times 6, which is 18. Okay, this is getting a little bit messy. Let me erase these. And 5x equal to 5 times 6, which is equal to 30, right? So the quantities are 18 and 30. And it's right, if I add 12 units to 18, it will be 30, and 30 to 30 is 1 to 1, right? So I hope you got this one. It's easy. I know you can get it. And this was finding the unknown in a ratio practice questions. Going for the second part, proportional division. The name must be very fancy, but it's not. It's a very, very simple topic. So it's like this. When you want to divide a quantity according to a ratio, first find the sum of the ratio parts, so the sum of the denominator and the numerator, then divide the total quantity, okay? Then divide, the total quantity that has been given to you by this sum, or by this result of the sum, and multiply the result by each part of the ratio. So it says that if we have a total amount, and I need to, separate or divide this amount to, a ratio, how can I do that? And how can I know that, the results are equal and the results are fair? So for that, take a look at this. A total of 20 is divided in the ratio 1 to 1. Find the two parts. Firstly, sum the denominator and the numerator. So 1 plus 1, which is 2. Secondly, divide the total number by the sum. So 20 divided by 2, which is 10. And thirdly, come and I'm mixing this up a little bit, but come and multiply the result of the division by the denominator and the numerator, right? So 10 times 1, right, which is 10, and 10 times 1 which is 10. Okay, the two parts are 10 and 10. Okay, so if a total amount of 20 is divided in the ratio of 1 to 1, 1 to 1, it's 20 divided by 2, basically. So the two parts are 10 and 10, right? Okay, a sum of 96 is divided in the ratio 3 to 5 to 4. Find all three parts. Okay, 95, firstly, as always, I need to find the sum of the parts of the ratio, which are 3 plus 5 plus 4, and this is 12. The second part, 96 divided by 12, right? 96 divided by 12, which is 9, right? 9, the result is 9. And the third part. Now, we need to multiply the result of division by the parts of the ratio. So, 9 times 3 equal to 27. 9 times 5 equaled to 45. And 9 times 4, which is equal to 36. And these are the three parts that we have been looking for. And this was proportional division. Going for the second and last part, proportions properties. Starting with the first one. The first one says that if A divided by B is equal to C divided by B, then A and C are equal. Okay? It's like this. So for example, 1 divided by 2 equaled to x divided by 2. Because the denominators are the same, and because we know that proportions are equal, we can understand that x is equal to 1. Going with this one, this is exactly the same, but with the denominators this time. So 1 divided by 2 equal to 1 divided by x. Because the numerators are the same, we know that x is equal to 2. Okay? The whole point of this property is that if the numerators are the same and one of the denominators are unknown, we know that that unknown number is equal to the other denominator of the other ratio of the property of the proportion. So yeah, this was the first one. Going with for the second one, A divided by B equal to x divided by y. C divided by D equal to x divided by y. We know that A divided by B is equal to C divided by D. Okay, so this is basically like this, like 3 divided by, for example, 5 equal to 3 divided by 5, or 3/5. And 18 divided by 30 equal to 3 divided by 5, okay? Because both of them are equal to 3 divided by 5, we know that 3 divided by 5 is equal, oopsie, this is not 3, this is 5. 3 divided by 5 is equal to 18 divided by 30. Okay, let me write the equation symbol in here. And this is the answer. Please pay attention to these properties because I'm using the simplest examples, but in most of the times you would not notice, you would not notice so many things in so many questions, and these properties will help you a lot. So please practice them with yourself and please pay attention to what I'm saying as well. The third property, A to B to C equal to D to E to F. This means like this. For example, 1 to 2 to 3 equal to 2 to 4 to 6, right? So this is basically equal to 1 half, right? So AD, BE, and CF, right? 1/2, 2/4, 3/6, and all of them are equal to 1/2, which is 0.5. Okay, and this is why this property is valid. The next property, the fourth one, is A divided by B equal to C divided by D. This is basically cross multiplication that we've been learning this whole time. So for example, 1 divided by 2 or 1/2 equaled to 2 divided by 4, right? So doing the cross multiplication, always and always, okay, these two are extremes and these two are means. Always write the result of the multiplication of extremes in the numerator part. So 1 times 4 and 2 times 2, right? Which both of them will equal, 1 second, both of them will equal 4 to 4. And because both of them are equal, this will be 1, the result, right? The whole point is that, write the result of extremes in the numerator and the means in the denominator. And this is cross multiplication and the fourth property of proportions. And the fifth property, this is the last property that we will learn today. It is like this. A divided by B equaled to C divided by D, which is A divided by C equal to B divided by D. Have you noticed the change? Is there something that has been changed? Yes, okay? The placement of the means are changed, right? They're replaced with each other. This one, take a look at this. This is the exact same proportion to this one, and this time the placements of extremes have been changed, or they have been replaced, right? And this one, this is exactly the same as this, but in here both extremes and means are exchanged or replaced. The whole point of this property is that if you change the placements, or if you replace the means, the property won't change. If you replace the extremes, the property won't change. If you replace the means and the extremes, the property won't change. So let's do an example for the last one. So 1/2 equal to 2/4, right? So I'm gonna change the placement of, or let's say it like this. I'm gonna replace the means and extremes, both of them. So 1 is replaced with 4 and 2 is replaced with 2, which is basically the same, but to do the example, let's just do it this way. 4 divided by 2, imagine that this 2 is this 2 and that 2 is that 2, okay? So 4 divided by 2 and 2 divided by 1, okay? Both of them are the same, and both of them are equal because 4 divided by 2 is equal to 2 divided by 1, right? 2 divided by 1 is our answer. And this is why this property is valid. It only talks about the replacements of means, extremes, or of both. And we have 3 more properties, but these properties, we will cover them in the next lesson because these need more practice. And we're done with today's lesson. Thank you for being with me. If you've got any question, feel free to ask in our Discord channel, and the link is in the description part, sources page.